You recall from an earlier module in this chapter that the only way that we can conditionally run code is by examining the exit status of a particular program. This is how the if statement decides which block of code should get run. Now, if you're a programmer, you might see this as a somewhat limited form of using the if statement. You might be used to seeing constructs like if x is greater than 6, or if a equals b, or something like that. And you might be wondering whether the if statement in shell programming is useful at all, because it doesn't seem to support such notion. Well, there is a way that we can actually do that sort of testing, and we're going to learn about that in this module. Now, the first thing that we need to know about all that is, and this is for the non-programmers, that in general, in a programming language, it's usually possible to compare two values together and do something based on the result of the comparison. For example, you might want to test two values, and when I say two values, I mean either perhaps two variables, or compare a variable with a value, and compare them for equality. In other words, is x equal to 6? And do something if it's 6, and do something if it's not 6. We can also test for inequality, to see if one is greater than the other, less than, etc., etc. Now, it should be noted that the Bourne shell does not natively support such comparisons. The reason for that is that the Bourne shell really doesn't support the notion of integers at all. You might recall that I mentioned earlier in the module on variables that all variables in the shell are strings. There are no integers, so you can't really say if one is greater than another. However, all is not lost. There is actually another Unix program called test that is perfectly capable of doing such comparisons. And we find that the test program is actually used quite a lot when you're writing shell scripts. Whenever you need this particular sort of comparison, you lean on the test program for that. So let's have a look at how test actually works. Suppose we set a variable called var1 to be 10. Then we can run the test program and we can test whether $var1 equals 20. In other words, we're comparing var1 with 20 to see if they are equal or not. Now, interestingly, test does not produce any output. You don't get a message on the screen telling you whether they're equal or not. All that test does is it changes its exit status according to the results of the comparison. Now, the sharp ones amongst you may be already guessing where this is going. So, what we can do is we can think of this exit status as a true or false value. This is where true and false really start to come into play, and this is the first time that they actually do. In the above example, we say, well, var1 equals 20. That is a test. That is a comparison test. So the statement var1 equals 20 is either true or it's false. And test will return an exit status appropriate to that particular true-false value. In this example, of course, we get a value back of 1, which we've already decided that we're going to treat as false. So let's just do a little visual check on that. Is that statement false? Well, it is, because we've already set var1 to be equal to 10, and 10 does not equal 20. So the statement 10 equals 20 is, of course, false. If var1 was originally set to 20, then the exit status of the test in that example would be 0, which of course would mean true. Now, as many of you will have already guessed, test was actually designed for specific use with the if statement. And here's an example of how you might use that. You might have a variable called var1, and you might have another variable called, let's say, max. And we can test them using the -gt option. -gt means greater than, gt for greater than. So we read this, we say if var1 is greater than max, then we can say, well, that value is too large because it's greater than the maximum. So as you can see, this is actually a very handy way. It is slightly long-winded, but it is a handy way of comparing two values. Sadly, we can't use the greater than symbol. The greater than symbol is already used by the shell program to redirect output to the file, as you probably already know. Now, a couple of notes when using test. These are quite important. I really think you should keep these in mind, or you'll get all sorts of errors in your scripts. The first is it's the spaces around the equal sign. You absolutely must have spaces around both sides of the equal sign. If you don't have them, it certainly will not work as expected. Now this is somewhat confusing because when you assign one variable to another, or when you assign a value to a variable, you absolutely must have no spaces around either side of the equal sign. So it might seem to be inconsistent. It's not really, because when you're assigning variables, that's done using the shell, and when you're comparing variables, that's done using the test program. So they're actually different programs. And the second note is that if the variable has actually not been set at all, or has been set to nothing, in other words, you might just type in x equals and then just press enter on the command line, which will set the value of x to nothing at all, then if you actually use that variable with test in some sort of comparison, you'll get a syntax error. Let me show you a demonstration of that before I show you how you can actually fix it. So suppose I have a variable called x and I just set it to nothing like that. That actually works. There's no error involved in that. It's just x is now equal to nothing. So now I can say test x equals 20, and I get an error message. Now it's a very subtle thing, but I'd like to actually explain why we're getting an error message here. You have to understand that before test even gets to have a look at this command line, the shell gets in and processes the values involved. In other words, the shell will look to see if there are any special characters on that line, and it finds one with the $sign. And it says, aha, there's a $sign. So that means instead of actually having the $x there, I'm going to replace that with the value of the variable called x. And what is in x? Yes, well, you guessed it, nothing at all. So it actually, if you like, you can think about it as the shell comes along and actually just removes the $x from that line in this particular example. Or to put it another way, it replaces it with nothing at all. And so all test sees is the following line, test equals 20. And that's all. It doesn't see the $x, doesn't see anything. So that's obviously some kind of syntax error for test. It's expecting something to be made equal to 20. So let's now have a look at how we can fix that. We enclose the variable inside double quotes, like so. We say test, and then var1, instead of var1 by itself, we put var1 surrounded by double quotes. Now, it's actually a really good idea to make this a good practice. Do this, well, all the time, unless you can absolutely guarantee that var1, or whatever variable you're using, has actually been set to something. If there is even the remotest 1 in a million possibility that the variable you're testing might not have been set yet, then you must put double quotes around the variable, otherwise you'll get a syntax error with test. So let's have a look at our example again. So now we say test $x equals 20, and we did not get any syntax error. Let's find out whether it is 20 or not. Well, it's not 20. 1 means false, remember? Now, the reason that this actually works when it didn't work before is, well, let's have a look at it. The shell comes along as before and looks for special characters on the line. It finds the $x and removes them completely, so we essentially end up with just 2 double quotes next to each other, enclosing nothing, if you like. Now we call this the empty string. Now technically the actual double quotes are removed as well, so you might think, well, we're left with completely nothing, like we were left with before. But interestingly enough, the shell actually treats the empty string as something. It treats it as a parameter. So when the test program runs, it'll find that it actually has 3 parameters after the word test. It'll have an empty string followed by an equal sign followed by a 20. And that's what test needs. It needs 3 parameters in this particular case. Whereas before, when we didn't have the double quotes around it, it would only get 2 parameters, the equal sign and the 20. It's a very subtle thing, I know, but if you don't really understand it, that's okay. Just keep in mind that you should always enclose your variables inside double quotes if there's any chance that the variable might not be set, or might be set to nothing. Anyway, let's move on and have a look at some more options that test offers us, some ways that we can use this very useful program called test. So some of the useful options for test are as follows. We've already seen test whether one value equals another. The test will return a 0, which we can interpret as true if the values are in fact equal. And then we've got the not equal or different, which is an exclamation mark before the equal sign. That's the symbol for not equals in the shell programming language, or rather in the test programming language. We've also got greater than, GT, minus GT, which will actually only work if both value 1 and value 2 are integer values or numeric values. If one of them is non-numeric, you'll get an error message from test. And we've also got minus LT for less than, minus GE for greater than or equal to, and minus LE for less than or equal to. What else have we got? Well, we can just say test value by itself, not really comparing it to anything. And what we will actually get back is a true-false value, and it will be true if the value is actually non-empty. In other words, the variable, if there is a variable, has been set to something. Now, obviously, if you're testing that, then there's obviously a chance that it might not be set to something, and if that's true, if that is the case, that it might not have been set to something, then you really need to enclose value in double quotes. Now there is an opposite test for that as well, test minus Z, or Z. Z stands for 0, and this will actually return true if the value is empty. It is of 0 length, sorry. So those are a bunch of options for testing the values of variables and comparing one variable to another. We also have some other options that can be used with test, and that actually really have nothing to do with variables per se. They have to do with files and directories. So let's have a look at those. We've got test minus F. Notice that the minus F is actually the first parameter to test. Now this returns true if the file that you specified exists and is a regular file. In other words, it's not a directory or a device or something like that. And we've also got test minus D, which is exactly the same, but it will actually return true if the file exists and is a directory. If it's just a regular file, then it will return false. We've got a couple of other options. We've got test minus S, which will return true if the file exists and has a file size greater than 0. Now it doesn't actually test to see whether it's a regular file or a directory or anything like that, it just tests its size. Directories too can have a size, so bear that in mind. And then we've got test minus R, or test minus W, or test minus X, which will return true if the file exists and is readable or writable or executable, depending on whether you specified minus R or minus W or minus X. And it will only test to see whether it's read, write or executable by the current process, meaning that the file may indeed be writable, but if it's not writable by this shell script, then you'll get a false value. Let's have a look at some examples of those. We'll do a test minus F of slash etc slash password, like that, and we'll echo the result out like that, and that is a regular file. We'll do a test minus F of slash 123 slash 456, and that turns out to be not a regular file. We can test for a directory. We might have, we can just test the current directory like that and echo $? Or we can set a value, a variable called dir to be slash etc slash, I don't know, garbage, and then we can test whether that directory exists, like so. And of course, it doesn't. Now we'll see if the slash etc slash password file is writable by us. Let's check that out. That's test minus W slash etc slash password, and it is not writable by us. So that's a collection of handy options for test. Now there's a few more that aren't really related to files and directories, and they aren't really related to comparison either. They're kind of special ones. Let's have a look at those. These are used in combination with the options that I've just shown you. Test exclamation mark expression. Now you read the exclamation mark as the word not. So you can think of this as returning not the expression. So if the expression is false, then test will give you a value of true, and vice versa. And the expression is one of the things that we saw earlier. Like, is the file writable? Then you could say, well, I'll show you an example. Now we've just tested to see whether etc. password is writable, and we found that it's not. So now let's test to see whether it is not writable. And we find that that is true. It is true, so etc. password is not writable. We can also test to see whether two expressions are both true using the -a option. -a is short for AND. You can read this as saying test to see if expression 1 is true and expression 2 is true. Now I'll give you a little demonstration of that as well. Here's a little script that ties everything together. We're using test in conjunction with an if statement, and we're actually using an elif clause as well and an else clause. So the first thing we do is we ask the user to enter a file name, read it in, and the very first thing we do is we test whether they actually did type it in. And if they didn't, then we give them an error message. Now if they did, then the next thing we test is whether the file that they specified exists, using test -f to see if it is a regular file and not a directory. And then we also test using the -a option for AND to see if it is writable by us. And if so, we specify the appropriate message. So let's see this in action. The first thing we'll do is we'll run the program, and it says please enter a file name, and we won't. And it says you did not enter a file name. That is correct, I just pressed enter. Okay, we'll do it again, and this time please enter a file name, and I'll just enter some garbage. The file is not a writable file. That sounds pretty reasonable. And how about if I run it again, and this time I say a file name of dot. Now dot is a directory. It's writable, but it's not an actual regular file. So we'll say it's not a writable file. It's actually a writable directory. Let's now try a file that is not a directory. It's a regular file, but it's read-only, and that is not a writable file. That's correct. And finally, we will try a real writable file, which, well, we'll use this one. Test file is the name of this actual program, and everything is fine because that is an actual writable file. Excellent. So that's the -a option in action. Similarly, there is a -o option. The -o is short for OR, and you can read that as saying test will return true if expression 1 is true or expression 2 is true. In other words, if either one is true. Finally, we come to a very interesting fact about the test program. Test has an alias, and the alias is the open square bracket. Now that's a very odd name for a program, but that is an actual valid program name. So what I'm saying is, anytime you could have typed in the word test, you can now type in the open square bracket symbol instead. Now, why would they do such a thing? Well, let's have a look. It means that our earlier example could have been written like this. Our just test to see whether one variable is greater than the maximum. So we use the open square bracket instead of the word test. Now notice that there is a closed square bracket there on the end of the line. And that's one of the curious features of the test program. If you use the alias of the open square bracket, then test will actually give you a syntax error if you forget to put in the closed square bracket. But if you just use the regular word test, then you don't need the closed square bracket. Let's just check that that actually works. I'm going to rewrite that little script that I just showed you. Let's have a look at that. Here's that script, and now I'll just go to this word test and put a bracket in like that, and I'll do the same thing here. Now, because I'm using the square bracket, I actually have to use the closed square bracket, and I'll do the same here as well. Okay, well actually, no. What I'll do is I'll omit the closing square bracket there, and I'll run this program and see if it works. So it says, please enter a file name, and so I will enter one. Now, notice there missing close square bracket. So I'll run it again, and this time I'll put the square bracket in, like that, and execute that. Test 1, 2, 3. File is not a writable file, that's fine, but notice that I did not get an error message, which means, of course, that the closing square bracket fixed the problem. Now, why do you suppose that they've invented this particular curious alias for the test program? Well, if you've ever been a programmer before, then you might actually feel more comfortable with surrounding your test conditions with brackets. To your eyes, that might actually look like a more valid use of the if statement, which is, of course, exactly why it was done. So it would look more like an if statement from, say, the programming language C. Now, C uses round brackets instead of square brackets, but the round brackets were already used for something in the shell, so they invented the use of the square bracket. So it's still the test program there, it's still running as the program called test, but it's pretending to be integrated into the shell and just a valid part of an if statement. So that's a little bit of cleverness there on behalf of the people that designed the test program. Now, because using the square brackets is actually much more intuitive when you get used to it than using the word test, or at least I find it to be, and most programmers that I know find it to be, this is actually the preferred use of the word test. Very few people actually write out the word test, T-E-S-T. Most people just use the square brackets notation because it looks better. It looks aesthetically more pleasing to the programmer's eye. So that's it. That's test. A very, very useful program. Probably 90% of the time that we use the if statement, we're also using the test program as well. Okay, let's move on.